So when you're throwing yourself at this question, you remember that you've been programmed to, what's your smooth way of finding the range of a function? What's your smooth way? What? Find the domain of the inverse. You've been programmed to find the domain of f inverse equals the range of f. 小英文还是 chu? 没关系 for now. So the problem is if you try to do that, what happens? Yeah, it gets pretty nasty pretty quick. You might be able to run that quadratic formula trick I showed you, but does it really work? Not so much. If you are allowed to use your calculator, what's always something that could help you? And see what it looks like, at least. Let's see what it looks like. So what was the function? It was, I gotta get rid of this a value, sorry. And I gotta put parentheses, right? 3x squared plus, we're gonna say 4x because there was disagreement. We're just saying 4, okay? Divided by, it doesn't change the methodology at all. 90? Yeah, we're saying 90x. Does it change the methodology much at all, kids? Does our method change? No. It's okay if I call it that. Is that okay? Can we just agree on that? Because I can guarantee as a class you chose different numbers for these. We're choosing this, mainly because it's what I chose, so deal. So if we zoom standard on this, you should see a little blip right in the middle. Blip. So let's actually zoom in. Let's actually do, just do zoom in. It's kind of nice, I guess. Zoom in. It blips up. So when you look at this, you might think that x equals 0 is a what? You might think it's this. You might think it's an asymptote, right? If you bring the window out a little bit, though, we make it x max at being, I don't know, like 3. Let's make it 4. Not 34. 4. If we make it 4, all of a sudden, it might still be an asymptote because it might get really close. As we know, is the resolution on these calculators very good? No. What you can do is you can zoom in. It actually does cross. And how can you test if it crosses? Well, can x equal 0? Yeah, I can't plug in 0. What do you get? 15 over 5 is? 3. So you do know that on this function right here, you do know that it crosses the y-axis at 3, 0. Exactly. So right here, we know that it's there. It is 0, 3, right? It doesn't really look like it's negative. You can actually prove that algebraically, but visually, what does it look like the range is going to be? Y is going to be less than or equal to 3 and greater than 0. We can look at this. Can this equal 0? For a fraction to equal 0, what has to equal 0? The numerator, right? Now, you could test it. You could do 3x squared plus 4x plus 15. Can it equal 0? How do you find it if it equals 0? You hope it's... you hope it's nicely factorable. Very good. Is it nicely factorable? No. So what do you have to use? Quadratic. Specifically, we're only interested in does this have a solution or not. So what part of the quadratic are we going to look at? Yeah, b squared minus 4ac, which is called the discriminant. So if we actually look at the discriminant here, we have 4 squared minus 4 times 3 times 15, and that's definitely less than 0. So what does that tell you? Does this ever cross the x-axis? No. So it's definitely greater than. Now here's the thing. This part is, I'm okay with this. What about, do we know for certain that the highest value is 3? It looks like it, but is it definitely there? No, because look, for it to be 3, you might expect this to be an even function. Is this an even function? Is it an even function? No. Is it an odd function? No. If you do this, what would be a good way to find out in precalculus land if that's the highest point? What could you do? There's a couple things you could test. To do what? What are you going to do? You could do maximum. I like that idea, actually. I haven't run that yet. Second calc. Let's do that. Maximum. We need a left bound, right? Left bound and a right bound and then a guess. Ooh, look at that. So what does that tell us? Oh, dang it. I wanted that. Cancel. So I'm going to pause that and do it again. Sorry. You can look at this as a preview for calculus here, but you could use a table of values or you could use maximum to prove that the maximum is somewhere else. Okay. It has to be always increasing or decreasing. So for this to be a one-to-one function, this thing is going to be always decreasing. So it has to be less than 11 and it has to be Why can't it be 4? Like, why can't you put the point there?
Because then it would go down and then back up.
Yeah, what we're assuming here is continuity, meaning you have to connect the dots with a continuous line. Idea of continuity, you had some questions about continuity on your benchmark exam. Continuity essentially means you can make the you can draw the function without lifting up your pen. So if you connected these points with a continuous curve, if it was below 5, it would cross 5 and it wouldn't be automatically be a one-to-one function, not a one-to-one. So if you want it to be one-to-one, there you go. Maybe I like the fact that what can x not be. I like that because it makes it a little harder. You have to find out what x should be and then tell it what it can't be. So x can't be greater than or equal to 11, and it can't be less than or equal to 5. Okay, let's see if there's any more you want to talk about. I kind of like this one right here. How do you, and I'm going to throw one thing into this. I like this one. This is a good one. Good job, Sean. Good job, Sean. It is Sean. It's yours, right? Isn't that yours? This one? Yeah. Oh, it's Alan's? Sorry, Alan. Didn't give you the right credit. Good job, Alan. So for this one, what's one thing we could do to make this question a little bit more clear in what it's asking for? This function, you can figure it out because what type of this function is not what? It's not one-to-one. It is a parabola. It's not one-to-one. So one way you can make this easier to answer or clearer, you can make it a more effective question if you said the domain is, let's make it greater than 0. That just helps us have singular answers. You can answer this. It just makes it a little cleaner and also makes it fit the fact that you like inverse functions. You like one-to-one functions when you're trying to find the inverse. Okay, so if we want to find f of f inverse of 910, what do we have to find first? F inverse of? If we want to find this, what do we have to figure out first? Nope. That's what we need to find out, right? Correct? Yeah, you could do this numerically, or you could just do it graphically. You're going to have to go to graphically anyway, because once you start throwing 910.25 into the other side of this equation, is it going to be nicely factorable? Alan's like, yes, that is nicely factorable. No, it's not. If this is the question we need to answer first, correct? We haven't figured out how we're going to yet, but if we want to answer that question, that is the same as finding out what? F of equals what? What's another way to say that? F of question mark equals 2, 5. Do we know what f of x is? Yeah, what is it? X squared plus 7x plus 2 equals 910.25. Now, here's the deal. That's a quadratic. Yes, every quadratic is factorable. You could use the quadratic formula. If you wanted to use your calculator, could you? Absolutely. Let's do a little 39. So we're going to do that again. So what did we do? We entered in the equation that we want to solve for 0. We're going to go back to the main screen here. Clear math. The bottom one on math is solver. By default, it will choose y1 now that we've specified it, and you need a guess. You need to give it a guess. It always saved the last state. So if we plugged in 50, that's our guess, and did alpha solve, it looks, oh, look at that, 26.839. So if that's our answer to the first part of this question, are we done? No, we're not quite done. We found the function. That's f inverse of 910.25. What do we now need to find? F inverse of this. Now, on your calculator, should you ever have to do out that number? No. What did it save that number as on your calculator? Well, look what happens. If I go back to my main screen here, everybody, and I type in x and press enter, look, there it is. If the calculator says x equals or y equals, what does it actually save that value as? X or y. You have to be careful, though, because how many different functions use x in it? Many. So every time you use a maximum, what's it going to do to that x value? It changes it. If you pick up a random calculator right now and type x and then enter, you're going to come up with some value that relates to something you did way back when. Or maybe actually not that long ago. Okay, so how do we go about finding that value? We need to do f inverse of that value. Well, how did we find f inverse of the original value? Yeah, so let's do this here. It's this right here. How did we get 908? We did 2 minus that, right? correct?
Correct.
So let's do this here. There's a shortcut you can use. So since x gets always overwritten, let's just check this here. There's x. You can do x store and store it as a different letter. So anytime you have the a value, what is a going to be? That value. So if I go back to here, and how did we get 908? It was 2 minus 910.25, right? So instead I'm going to do 2 minus what? 2 minus what? You see how I put parentheses around that? And now what can I do? I can quit out of this and go to math and then solver. Well, let's keep the same guess. Let's say we hope it's positive. Well, maybe it's positive. Let's just take a guess here. If we run the solver here, alpha solve, 2 point something. Let's see. Ooh, no sign change. So if there's no sign change, it means our guess is pretty poor. Our guess is pretty poor. So let's try a better value for our guess. Now, how would you get a guess? How did we get our initial guess of... How did we get our initial guess? What did we look at? We looked at this basic graph and we knew it would be positive, right? Basically our guess wasn't good enough if there's no sign change. So let's go back here and see if a different guess can actually help us. What's the limitation on using solver on your calculator? What do you need in order to use solver? No, you have an equation for graphing or using solver, but the limitation on using solver, what did we have to give it before it would give us an answer? I guess. Limitation on using solver is that you need to supply a guess. And usually, how are you going to find that guess? What are you going to do? You're going to graph it. And if we're trying to avoid graphing by using solver, it kind of defeats the purpose, right? So it might save you a little work. If the function's already typed in, it might work. But solver is just a nice way to get some zeros quickly. It's a built-in function on your calculator. It's there because you can use it in programs. If you write programs that need to solve something, it's a single line command that will pump out answers for you.
Can you test out using solver?
F of g inverse, what do you have to find first? F of g. And F of g means you're plugging what into what? Oh, not GF. You want to plug g into F. So that's going to be 1/8 g of x minus 3. But what's g of x? So it's 1/8 minus 3. So, if you want to find the inverse of that, we want to inversify this. Yeah, I like making up words. It's a good time. X equals 1/8 y cubed minus 3. X plus 3, 1/8 y cubed. So what does y cubed equal? What does it equal? How do you get rid of a cube? Yeah. Do you have to worry about plus or minus in this case? Why not? Why don't you put plus or minus? It's a cube root. It's an odd root. Odd roots don't change the sign. What's the cube root of -8? -2. Doesn't change the sign. Doesn't change the sign at all. Okay, so there is our inverse. Very good. I like that. That's good. Very nice. You choose which door you want to open. B. I open door C, and there's nothing behind it. The question I have for you is, do you want to change your guess, or do you want to keep it where it is before I actually open the door that you have chosen? That is the question. To be more specific, if the prize is randomly assigned to one of the doors, and you randomly pick your choice, there's always going to be at least one empty door that hasn't been chosen, right? Because there's 2 empty doors. Does it matter if you change your guess? That's the question. Meaning, there's 3 outcomes to this. Yes, you should change your guess because you will win more often if you change your guess. No, you shouldn't change your guess because you will lose more often if you change your guess. Or, it doesn't matter. You have the same chance if you change or keep it the same. So I'm not going to tell you the answer. I don't want anybody to say anything about this, but I want you to think about that. As part of your homework, and we'll talk about this on Monday, the one thing I'll tell you is play the game. Get somebody else, get 3 cups, put a bean behind one of them, mix it up, play the game. So mix it up, someone picks one of them, you show one of the empty ones, and then you ask them to change their guess. Keep track of how many times they win, how often they win if they change their guess, and how often they win if they don't change their guess. Use that to see if you could formulate a way of explaining one of these 2 things. I'll tell you that there is a definitive answer. It's either you want to change, you don't want to change, or it doesn't matter. One of those is correct by a significant margin. Okay? So that's the first question. Are there any questions about how this game is played? So again, you want the money, and no one's trying to trick you in the game. We good? Next one, infinite checkerboard. I love this one. It's a great question. So you have an infinite checkerboard. It's a really big checkerboard. It kind of looks like this. There it is. Here's the bottom left corner right here, and it extends infinitely like this. It keeps on going forever. It's a very simple game. It starts with one checker piece. You see the checker piece right there? There's only one thing you can do with any checker piece. You can remove it from the board and replace it with two checker pieces, one above and one to the right. The only other rule to the game is only one piece can be in one spot. Each space can only have one piece in it. Meaning, I could then move this one. I could then move this one. Can I move this one? Nope, because this piece has to be moved first. I move this one, and now can I move this original one? Now it can go here. Can I move this one? I have to move this one first, but then I need to move that one. But to move that one, what do I need to do? Oh, this one. Then I need to move this one, and now, hey, can I move that original piece? Yeah, there it is. So do you understand the movement mechanics? The only thing you can do is pick a piece up and replace it above and to the right. That's the only thing you can do. No space can have more than one piece in it at once. So that's the game. How do you win the game? It's pretty simple to win the game. You see that? You win the game if there are no pieces in that shape. You win the game if there are no pieces inside that little stair-shaped shape. It's pretty simple to win. So the question is, can you win? How? So if you think you can win, how? So there's three outcomes. There's two outcomes to this. You either can win it, in which case you need to tell me how you did it, or you can't win it and you need to tell me why you can't win it, meaning it's impossible to win. So basically the question is it possible to win this game? My recommendation for this, same as the door game, play it. When you play this, try to get a whiteboard or something that you can erase really easily. Get little pieces of paper. It gets pretty crazy. The first time I saw this question about 10 years ago, I had a little whiteboard and it got a little messy. Try it. Do you understand the mechanics? We're good? Okay. So the next one is the proof one that I want to talk about. It's this magical number called the square root of 2. What can you tell me about the square root of 2? What? It's an irrational number. There you go, Alan. Can someone tell me with 2 words what irrational means in terms of numeric irrationality? Not what? It's not rational. Yeah. Irrational means not rational. Can someone tell me what rational means? What is a rational number? Real numbers are broken up into 2 sets. Irrational and rational. So a real number is either irrational or rational. So if something is rational, what does rational mean for numbers? A rational number, what are the first 5 letters of rational? Rational numbers can be written as ratios. Yeah, ratios. So you just need to remember for that, ratio. So what's a really, really super clear way to define an irrational number? Cannot be written as a fraction. Pi. Pi cannot be written as a fraction of integers. It can't. Ready to play a little game? It's going to be called Find the Contradiction. So we're going to start with an assumption. Here's the assumption we're going to start with. Root 2 is rational. Here's our assumption. We're going to start with that assumption. It's pretty cool. It's a neat little play of action here. If root 2 is rational, what does that mean you can write it as? Just remember, if you pack up, you unpack, and everything gets spread out. It means it can be written as a fraction. So therefore, root 2 can be written as p over q. Some fraction, right? Where p over q is most reduced. Don't move, everybody. Most reduced. What does most reduced mean? P and q have no common factors. We're going to do this in 2 minutes just to see if I'll get a little bit further and then see if you can find it. Okay, I'm going to set you up here. I'm going to multiply both sides by q, and you get this. Can you do that? Is that legal?
Yes.
Could I turn it into this? Yeah, this tells you that p squared is even. Because it's 2 times q squared. All even numbers can be written as 2 times something else. Do you agree? So therefore, 2q squared is equal to 2k squared. But what is 2k squared? 4k squared. What can I divide both sides by? So q squared is... So therefore, q squared is even. What did we just prove? Q squared is even and p squared is even. This is what I want you to do for homework. Study, because you have your Unit 4 test tomorrow, and think about these 2 problems I gave you, and can you finish this? Yeah, the root 2 one.
You almost finished it.
Oh, it's almost done, but the last step is very... You have to realize what the last step is. You're looking for a contradiction! Again, main thing, study for Unit 4. Game over. Goodbye.